Hello everyone, I am Parvati Angdi from Sri Venkateshwara College of Engineering in Bangalore, USN 1VE23 EC 069, semester 2nd, section Infinity, subject Mathematics 2. Today I am going to discuss about vector space and linear transform of application of reflection. Introduction to vector space and linear transformation. Vector space is a mathematical structure that consists of vectors and operations like addition and scalar multiplication. Linear transformation is a mapping between vector spaces that preserves vector addition and scalar multiplication. Reflection is a linear transformation that flips vector across a linear or plane. Properties of vector space. A vector space must satisfy properties like closure, under addition, and scalar multiplication. Vectors in a vector space can be represented geometrically as arrows with magnitude and direction. The zero vector in a vector space is the unique vector that when added to any vector gives the same vector. Definition of a vector space. Let V be a set on which two operations, vector addition and scalar multiplication, are defined. If the listed axioms are satisfied for every u, v, and w in V and every scalar in the bracket real number C and D, then V is a vector space. Definition of linear transformation. A linear transformation T between vector spaces V and W satisfies T of U plus V bracket complete is equal to T of U plus T of V and T of CE is equal to CT of U for all UV in vector and scalar C. Linear transformation can be represented by matrices where each column corresponds to the image of a basis vector. Linear transformations can be composed by multiplying their associated matrices. Reflection as a linear transformation. Reflection is a type of linear transformation that reverses the direction of vectors across a specified line or plane. The reflection of a vector v across a line L is given by R of v is equal to v minus 2 of v dot n of n, where n is a unit normal vector to L. Reflection is an example of an orthogonal linear transformation that preserves lengths and angles. Reflection over x-axis multiplied by matrices 1 0 0 minus 1 reflects over y-axis multiplied by matrices minus 1 0 0 1 reflect over y is equal to x multiplied by matrices 0 1 1 0 reflect over y is equal to minus x multiplied by matrices 0 minus 1 minus 1 0. Application of reflection in geometry. In geometry, reflection is used to mirror objects across a linear or plane to create symmetrical figures. Reflection is commonly employed in computer graphics to simulate the reflection of light rays of surfaces. In physics, reflection plays a crucial role in understanding the behavior of waves and particles. Next, eigenvalues and eigenvectors of reflection. The eigenvalues of a reflection are 1 and minus 1, representing the invariant and flipped directions, the respectively. The eigenvectors of a reflection are the vectors that remain in the same direction or reverse direction after reflection. Eigenvalues and eigenvectors provide insights into the behavior of linear transformations like reflection. Geometric interpretation of reflection. Geometrically, reflection across a line can be visualized as flipping an object over the line. The normal vector to the reflection line determines the orientation of the reflection. Reflection across a plane involves flipping an object across the plane, with a normal vector defining the reflection direction. Matrix representation of reflection. Reflection can be represented by a matrix that corresponds to the transformation in terms of basis vectors. The matrix of reflection across a line or plane can be derived using the formula for reflection. Matrix representation allows for efficient computation and composition of reflections in linear transformations. Matrix reflection of a figure. Reflection over x-axis multiplied by 1 0 0 minus 1. Reflect over y-axis multiplied by matrices minus 1 0 0 1. Reflect over y is equal to x multiplied by matrix 0 1 1 0. Reflect over y is equal to minus x multiplied by matrix 0 minus 1 0. Application of reflection in engineering. In engineering, reflection is utilized in designing structures for symmetric and balance. Reflection is applied in signal processing for filtering and noise reduction. In robotics, reflection is used to for path planning and obstacle avoidance. Designing reflection mechanism, learning objects to synthesize opportunities and challenges for retail operations in China. Associated guiding promo. How do I know understand the opportunity and challenges differently than before? In other words, what do I know see in the opportunity and challenges that I had not seen before? To evaluate competitive retail strategies in China. How specially might I explain the competitive retail strategies differently to express my enhanced understandings? Based on this enhanced understanding, how specific might relate in China need to act differently in the future, and what are the associated benefits and challenges? Conclusion. Vector space and linear transformations are fundamental concepts in mathematics and applications. Reflection is a powerful tool in geometry, computer graphics, physics, and engineering. Understanding the properties and applications of reflection enhance our ability to analyze and manipulate vectors in different contexts. Transform vector is equal to minus 2 of transform I vector plus 4 transform j is equal to minus 2 matrices 1 minus 2 plus 4 matrices 3 0 is equal to matrices ax plus by cx plus dy is equal to matrices 10 4. Thank you.